All right. This is the lesson for today. Are you able to get me? Okay. So we are talking about projectile motion. So you can see some of the things that you expect in an exam, especially like a small one down there. You're able to see? They have been bringing that in your exams. All right. So as we'll be doing the tutorial sheets, we'll meet this one. Okay. So one thing that I should tell you is that tell your friends also to be part of the session. All right. Yeah, yeah, yeah. I've mute. No one can hear. Just say what you want to say. Okay. Let's see what projectile motion is. Hope everyone is in the meeting. All right. Okay. Okay, so when we say a projectile, all right, so suppose this is a prayer, all right. Okay, so this prayer kick the ball, all right. So this ball is kicked, then it will what? It will go with a specific direction, all right. Finally, it will come back. Have you seen? So this ball, it will reach the ground again. So at this point, it had what? Its maximum height, all right. So it had what? Its maximum height. So it was what? It was what? It was beaten at a what? At a certain angle, all right. So that's what an angle is. So by this, then it at least what? Reached its maximum down there, the horizontal distance, and we can call this as range, all right. So the thing that what you throw is what we call a projectile, all right. So let's say a ball is now a projectile, all right. So a projectile is what you throw. Then that path which has been just taken by this path that has been just taken by the ball is what we call now a what? A trajectory. So sometimes if I ask you to say what is a trajectory, all right, a trajectory is now a what? A path taken by what? A projectile, all right. So basically that's what we mean when we say projectile motion. So it's a motion taken by this situation, all right. So that is it. So this projectile, they are what? They are of three scenarios or just types. Okay, the first one that I can give you is a situation whereby, all right, a situation whereby I give you a projectile there, all right. So suppose the projectile start from this point, then it goes up until finally comes what? The same ground. Okay, so this is the first case of projectile. Then the second case of projectile, we have a situation whereby we have, let's say, a building there, all right, to some height, all right. Then a projectile is thrown at the top there, all right. So this is a building. At the top there, it goes like that, you see, then it lands like that down there. Okay, so this is what? Another type of what? Projectile. Okay, so then the other one that I can just tell is a situation whereby you are seated there here on the ground, right? You traject something or you project something there, then there's a building, then it reaches the building there, all right. So this also will be trajected at an angle, this one will be also trajected at an angle, even this one at an angle like that. Okay, so they will all have what? They at least the distance of which they can what? Travel horizontally, and also they have the distance at which they can travel what? Vertically. All right, we'll talk to, we'll get to know all those things. Okay, so all these things matters with what you have. All right, so I remember you did this. So let's say all these three guys lies on three equations of motions, all right. So those equations of motion, we had what? Someone to give me three equations. Okay, so the other one is coming from final velocity is equals to what? U plus at, all right, at. So meaning that this is the final velocity, right? This is your initial plus what 80, which is just G sometimes. Then you'll get to know why we replace G, same as A. Okay, so the other equation that we can talk of is a situation whereby we have V squared is equal to U squared plus what 2. Sometimes you can say what 2 what. Okay, so there are people who replace that number with the G acceleration, or the other one height is S, but in this case I'll just put AS like that. Depends with how you know it. Okay, then the other equation that we can talk of is the one whereby you are given, let's say it's a distance formula. Okay, then you have what ut, then plus 1 over t like that, g, or just a, then squared, t squared like that. Okay, so these are the basically equations that we'll be using in this case. All right, so all these three guys lies on what, these three equations. Now when you are throwing something, right, this thing, let's say you are throwing something, this thing is not known whether it is going up or what, horizontally. It is moving in both directions, right? So it has a certain velocity at which it is moving, right? So we'll call it v0, or just the initial velocity. All right, so from there, then what are we going to do? We'll say this is the v0 we have, or just final velocity, or I mean initial velocity. So what do we do? Close the door. So what do we do? We say I want to resolve this in two components so that we can have something specifically which is goes up, I mean, and also which goes horizontally. So we'll say now, we remember how we were resolving vectors in two components. For y, we represented as what? As that vector we have. All right, in this case we have the vector which is what, it's more like the resultant in this case. Okay, this v0. Then for y you put what, sine what, theta. Then for x, all right, in the component, x component, we used to do what, under vectors we used to do what, 0, I mean final the velocity that we have, then cos what, theta. So in the x's we'll be using cos theta, then in the y we'll be using what, sine theta. Okay, so that is it. Okay, so that is it about trajectory motion. So let's see some examples. Okay, so we need to understand what so they are very simple. Projectile motion is very simple, so long as you just know these three equations and the data that is available for each projectile that you have been given. Suppose you have been given a projectile motion like this. Let's say it is projected at an angle. All right, so let's get to judge this scenario. All right, okay, so it was projected at a certain what, angle. Okay, so this is a projectile. All right, so the velocity that you start with is what we call what, v0. all right, okay, so it will have x component and I mean x component and y component. All right, you need to know that. Then once it reaches at its peak, at its maximum, you know, when something has reached there, it will stop, then start dropping, right? So the final velocity at this point is what, 0 in the y, because it's no longer going what, up. All right, but in the x, the velocity will still be the same because it's moving like this. All right, and you have no problem with that. Okay, so that's one of the data we can collect. Then after that, sometimes it will reach with the same, in the x-axis it will reach with the same velocity. All right, but in the y it keeps on changing. As you can see here it had what, it had 0. Then once it comes down here, the velocity I'm sure will change, because even the direction, the acceleration will be what, positive. So master that. So as it goes up, all right, the gravitational acceleration is now going to be negative. So we have been using 9.8. so in this case, once it is going up, then the gravity will be now negative what, 9.8 like that. So master that. Okay, then the height at which we can what, we can measure from that peak is what we call what, maximum height. All right, so this is what we call what, maximum height. Okay, then this maximum height is you can't just get it. For example, if you punch what it need to be, what's this, so let's say I throw something at 60 degrees, then it will land there. Okay, then again at 30 degrees, again it will land there. All right, then at 45 it will run there to get the what, the maximum what height. I mean, so for 45 it will go like that and it drops like that. So in short, what I'm trying to tell is that 45 is the one which will be giving us maximum height. All right, even maximum range. All right, so that's what we need to know. Then you need to know again to say here A is equal to B. So if you find the time taken to reach here, is you just multiply to find the time taken to reach also at this point. All right, so A and B, they are what, they are equal. All right, for this scenario, so I'll talk about this scenario. Okay, so for projector, you just collect the data that you have. All right, so let's drive some equations. All right, so the first one, I'll ask you to say, let's see the time taken for, so the time taken for project to move from this point, all right, from this point I mean from this point to that point is what we call time of flight. All right, then the distance covered from this point to this point, we call it range. All right, is that clear? Okay, so now let's see the time taken to reach at this maximum point. All right, this point here. Okay, so we want to see, so depends, I said they'll give you a what, a initial velocity, then the final velocity there, you know, is what, 0. All right, and you want time taken to reach there. So the data that you only have is what, the data that you have is initial velocity, final velocity. All right, then you have also acceleration. All right, then you need what, time. Okay, among these three equations that we have here, so the final velocity, let's say, is just a v0, right? So now we are going up, so we use the final velocity for what, for y. Okay, so we'll say v0 is equal to sine theta, like that. Okay, because we want the velocity what, in the y-axis. We are going up to see what time are we going to reach at the peak. All right, so the final velocity in this case, at this peak, it will be 0 because it will stop, the ball will stop, then start falling. So we'll say 0 meters per second. All right, then gravity now is going up, this will be negative 9.8. Then the time is the one we are looking. So it depends with this one. So this one has a distance and also this one has distance in it, so I'll use definitely this one. So what I'll do is I'll say v is equal to what, u, so this is final velocity, initial, all right, plus what, at, or just v is equals to final velocity, I mean initial velocity plus gt, like that. Okay, so sometimes you can say like that. So now the final velocity there is 0 at that point, at the peak. Then the initial velocity in the y, we said it will be given by 0 sine theta, like that. Okay, then plus the negative, the g now is what, negative, right? So we call this as what, negative gt. All right, so which can be 0 is equal to final velocity sine theta, like that, then minus gt. Okay, we take g to the other side, then it will be gt is equal to final velocity, I mean initial velocity sine theta. All right, so we divide throughout by what, by g. All right, so time of flight to reach that peak will be given by what, sine theta. Sometimes you can't even master, just collect the data that is there, then you'll be okay. So meaning that to reach at this point at the peak, you use what, this equation. Now for you to find the total flight, the time of flight, the time taken to reach this point, the end, so you just multiply this one times what, 2. All right, so you multiply this one times what, times 2. Okay, so you multiply this one times 2 to find what, total. So we can say now total, all right, is equal to 2 v0 sine theta over g. So this is the one we'll be using to find what, the total time of flight. Okay, so, or just time of flight. All right, so that is it about projectile motion. All right, so the other equation that we can drive is so hope that one you have mastered that one. It's just a matter of replacing the component value. All right, bx or y component. You just know that in this case we won't use the very velocity that it will start with, but we'll use those ones resolved in two components as our velocities. All right, so now what we are going to do is let's drive another equation just. All right, so in this case I'm going to drive the equation for you. Let's say we want to calculate the what, we are interested in the maximum what height. So let me just, this is looking dead, so let me light something new. All right, okay, so it will start at that with an angle. All right, so that's the maximum. At that point we said the final velocity is equals to 0. Then as it travel like that, so this what will be formed down is what we call the range, then this one is what we call the maximum height, or just the height. All right, at the peak, because that's the maximum height. All right, so it will reach, we don't know the velocity, sometimes it reaches, but in the x-axis, because it is moving like this, all right, the velocity will keep on change, I mean won't change in the x direction, but in the y, as you can see at the peak here, is equals to 0, so it will be changing, the final will change. So this velocity that will be given with, which is v0, it will be resolved into components. All right, so we know how to resolve into components. So this velocity that we have there, so it will be resolved into what, sine theta v0. Here is v0 cos theta. All right, in the x direction and in the y direction, like that. Okay, so it goes like that. Now we have derived this one. So let's see if we want to calculate the height now. All right, you look at the data that you have. So you say data. All right, it's very simple, just collect the data. So the data that you have, you need the height. All right, then you have what, the final velocity, right? You have the what, the final velocity with you as 0. All right, 0 meters per second. All right, then what else do you have? You have acceleration due to gravity, which is now negative 9.8, because you are going up at this peak. All right, we want to calculate this height. That's what we want to do. All right, so we are here to calculate the what, the height. Okay, so now what we do is we say the same thing, we collect the data. So what else do we have? We have the what, the initial velocity. All right, so the initial velocity, we are going up in the y, so that will be what, 0 sine theta. Okay, we'll be given any trajectory, it will always what, be given the initial. You can't have a trajectory without the initial velocity. All right, so that's the data that we have. You need h, so there's no time showing here, so I'll definitely go to this equation there. All right, so I'll say, so have you seen now the way I've collected data? So don't get confused, you don't have even to master the formulas, just bring the data and you know the velocity that we use in the x and in the y. Those ones resolved in two components. So some people, it's a challenge to master the formulas, but I encourage you to just come up with the data, then do what is supposed to be done. So I will use this equation definitely. So this is state that v squared, or final velocity squared, is equal to initial velocity squared plus what, 2g h, let me say h because the distance I want. So from there, then I know final velocity at this peak is 0, so I'll write 0 is equal to the initial velocity now is the one that, which is just in the y, which is given initial velocity sine what, theta what squared in this case, then plus, all right, plus, then we have what, 2g, now it is negative this gravity. All right, h, like that. So this is 0 is equal to what, v squared initial, then sine squared theta. All right, so that's the meaning there, right? Then from there we'll say now this is negative what, 2gh, then we cross, we take the other one to the other side, that will be now 2g. All right, h is equal to final initial velocity squared sine theta sine squared theta. All right, then you divide throughout by gh, by just 2g. all right, throughout by 2g. So these cancels, so we'll have what, we'll have h is equal to what, final velocity square, initial velocity squared sine what? Theta over 2g. So this is the maximum height for your formula. Alright, so this is the one we'll be using for formula. So sometimes you just have to see the data that you have. You can't really even master this. So this is the total height formula. Okay, so we are saying now total height, or just the height. Alright, height is equal to what? Final velocity square, initial velocity squared sine squared theta. So by the way, it's squared there, squared theta over what? 2g, like that. Okay, so that's another formula that you can derive. Okay, so they are not complicated. Sometimes we just want to complicate things ourselves. All right, so let me take you back again to, so we are interested only in the what? In the range, in the maximum height. So those are the formulas you should master. That's why they are here. This one will talk about the range. All right, this one will talk about the what? Maximum height. This one will talk about the what? The time. All right, so those are the, you can just see here there's no time, there's only height. Here there's what? Time. And so you calculate the range, it because two friends has been involved, the time and height. All right, so here you calculate the range. So that's about trajectory motion. I don't know why people fails this, but you just have to master them like this. So it depends with what you have. Gather the data and see which one is possible. So for this one now, let's see. We said I'll use this one to find the maximum because we need to know this R. All right, okay. So what I'm going to do is I'll use the same very last equation, which is that s is equals to, of which it is now the range I want. I place the distance that I want, depends with the data that I have. So let me collect the data first. All right, so the data that I have is what? So the first thing, let's say I want to reach here. So for me to reach here, I need to have what? My total time. So I'll say time will be given there. All right, so time, total time of flight, we said is this one, right? So we'll say, I can even input there. Okay, I can even input there. All right, so v initial sine theta. All right, then over what? Over g. So this is my time of flight. So what else do I need in this formula? I need to have what? My initial velocity, right? So my initial velocity is what? Is the one that I'll be given now in the x. So in the x now, when you resolve this initial velocity, we said is under vectors concept. So this will be cos theta, like that. Okay, initial cos theta, like that. So that's our initial velocity. Then what else can we gather here? Time we have already seen. Then time is already seen already. Then g, we have g there. All right, so the g that we want now is what? Is now going what? Is now going what? Down or up? Someone to tell me. So the gravity now at this point, all right, we are now calculating the maximum range. All right, so what we do is the gravity in the x is what? 0, because it's not moving. It's more like it's constant here. All right, there is no falling and there is no going up, so it is just within this horizontal line. Okay, our area of interest is within the, so this will be what? 0 meters per second squared. All right, so that's 0. So now let's come now. I said there's no acceleration in the what? In the x-axis, because something is just moving like this with a constant velocity. If the velocity was 2, all right, 2 meters per second, it continue maintaining that the same 2 meters per second. That's why we're saying velocity in the x doesn't change. That initial you had doesn't change. Okay, that's why we have brought this initial one. All right, so that's the meaning there. Okay, hope that is clear, guys. So what I'm going to do is I'll say this is now my what? This is now my data. So now I'll bring that equation. Okay, so that equation now gives me what? S, of which now name is at what? Range, is equal to u t, okay, plus half, all right, then g t squared, like that. So what I'm going to do is now I have the data, so I'll say range is equal initial velocity in the x now, that is given by v initial cos what theta. All right, that's just then times the time. So now I want the total time of flight because I want to fall at this point, so I need the total time. The total time, we said you just multiply that one with 2, and that's what we have put there. So I'll put 2 there. Okay, 2 v initial then sin what theta. All right, so that is it. Then from there I'll say plus half. All right, our g now in the x, it doesn't what change, so it's 0. There's no gravity acceleration in the x, so then t squared like that. So this will definitely give me 0, so I'll remain with the r is equal to what final velocity cos what theta, like that. So let me just give you one identity. So what you need to know is that we have this identity. All right, so when you are given 2 cos what theta sin what theta, this should give you what sin 2 theta. All right, sin what 2 theta. It's an identity under trigonometry. Just know that when you have 2 times cos times what sine, that will give you sin 2 theta. We'll talk about that in trigonometry. So for now, let's just master this identity. All right, it's an identity. Identity has to be mastered always. You have no option. So you can see there's 2 times what sin theta times cos theta. So that's combination that we can see there is the one which will give us sin 2 theta. So the initial velocity times the initial velocity, that will give me initial velocity squared, right? Then the one which the combination that we say 2 times sin theta times cos theta, that will give us what sin what 2 theta, like that. All right, then over what over g. So this is the formula that we'll be using to calculate the what the range. Okay, now that you have mastered this formula, so can we just see some examples? All right, so we'll give an example, then we'll be done from there. All right, so what we do is, now let's see. Okay, suppose you are given a trajectory like that. So we'll continue giving scenario 1. These others are not really difficult. We just have to do what? Okay, so it is started at this with a certain what angle, let's say 30 degrees. All right, then it had what velocity? I'll put 15. All right, 15 meters per second. All right, so I'll say velocity now in the x will be given by the same 15. All right, cos what theta. All right, then in the y it will be given by what 15. All right, sin what theta, like that. So those are the velocity in the in the y component and in the x component. Then at this point, the velocity, the final velocity is equals to what? To 0. Then this one here is what we call the what? The maximum what? Range. Okay, then here is what? Then from here to there, to this point here, that's what we call now the range. All right, so x, the velocity here doesn't change for in the x-axis, but in the y-axis I'm sure it will change. We can able to calculate the first final. So suppose now we are told to calculate the what? The maximum height, this h. So how do we do it? We collect the data. So the data that we have there to reach at this peak. So the data that you have there to reach at this peak is what? The data that you have there to reach at this peak, we have what? Final velocity, all right, which is 0. Then we have what? So this is the data that we have. We have also initial velocity, which is what? In the y now, that is what? 15 what? Sin what? Theta. All right, what else do we have? We have also acceleration due to gravity. All right, so since we have acceleration due to gravity, which is now negative what? Negative g, or just negative 9.8. all right, negative 9.8. okay, so I won't put the units. just like that. So those are the data, that's the data that I have, right? So I'll go to the equation that involves, since I want the maximum height. So the first question to say calculate what, calculate height. All right, then the B question I'll say time of flight. All right, time of flight. Then C, I can also say range. All right, okay, so those are the things we need to know. All right, okay, so let's go and see what will be happening. All right, so what we are going to do is we are now calculating the height. So in the height we have this data here, and which one is the best formula to use? I'm sure the best formula that I can use, as for me, I can see what so I have what v squared is equal to initial squared plus what 2gh, like that. Okay, so I'm interested in this what g, because I have final velocity, I have what initial, I don't just have time, that's why I've brought this equation. So what I'm going to do is I'll say final velocity is what is 0 at the peak, so I'll just write 0 there, then is equal to, all right, initial velocity is now what, initial velocity is now in the y, that is now 15 what sine what theta, like that. Okay, so that's 15 sine theta. Now it's what squared. All right, so you square that, so it's squared in the formula, then plus. All right, so what do we do there? What do you put? We have 2. All right, the gravity now is going up, that's negative what 9.8. all right, we are looking for what, for height, so this is negative, so we are saying 0 is equal to, when you square that, it will give you what will be your value when you square that? All right, so that will be positive what, that will be positive 56.25. all right, okay, then minus what is 2 times the 2 times the 9.8, that is what 19, but 19 point what 0.6, like that, h. So we take this one to the other side, so that would be 19.6 h is equals to 56. all right, 56.25, like that. We divide throughout by what, by 19.6. all right, so our now h will be what, you punch on your calculator. So punch on your calculator, guys. So once you punch on your calculator, that will give you what, 2.87. so this is 2.87 what meters. Height is always measured in meters, so that's how you can calculate the what, the height. So what other things? Time of flight, we say the time taken from this point to reach the here is just time, then you multiply times 2 to reach here. Okay, so that's what we said. Okay, so let's calculate the time to reach here. We said this side is equal to this side. all right, so we don't have to worry. So now the time of flight, we said it was given by the, looking at the data that we have only what, final velocity, everything like that. So the formula, that the best formula that I'll use is what, is this formula. all right, time of flight, because at this point I only have the final velocity, initial velocity, that's so there's nothing else I have. So what I will do is, the final velocity at that point is 0, then the initial velocity now, that is in the x, right, in the y, so I'll put what, v initial sine what theta. all right, then plus. all right, now is now negative, let's say put negative 9.8, like that, then t. So this will go to the other side, it will be what now, what, positive what, positive 9.8 g is equal to what, the final velocity now, I mean the initial velocity was what, 15 sine what theta. all right, so I forgot to press there. Once you press there, you put what, here you put 30 degrees. all right, inside there, so even here I'll put what, 30 degrees. all right, so then plus then you divide throughout by what, 9.8, and also what, 9.8, like that. So the time now, once you punch on your calculator, okay, so now that is giving me what, 0. what 0. 0.76 0.765 or okay, just okay, seconds. All right, so this is the time to reach at this peak, so meaning to reach at this total flight, now multiply times what, times 2, so that is now total. All right, so is equals to t1 that I have, then times 2, so I just multiply this number times 2. All right, so that will give me, once you multiply times 2, you are finding the total time of flight. All right, so the total time of flight now is, now once you multiply this one times 2, that will give you 1 point what, let me see, yeah, 1.53. all right, 33 seconds. All right, so that is it. That's about these guys. Then we can now calculate the C, which is now the maximum range or just the range. All right, so we remember what we had. We have total flight now to this here. All right, so we have the data total flight. We have also acceleration, of course this is 0 in that case. Then what else do we have? We have what we have, so we'll go to that equation which gives to say height, or just the maximum range, is now equal to ut, all right, plus half, all right, gt squared. Okay, so that is it. Then from there, then what we are going to do, we'll say the range is now, we substitute, this is now in the x, so I'll put v0 cos what, 30 in this case because we have got 30 degrees, then plus, all right, then there's t there. All right, so not forgetting that t, so I'll multiply times what, total time of flight, because we want to reach this point. So this is now what, total. All right, so let's say just t2, then plus I have what, half, then the g, there is no acceleration in the x-axis, so this is 0 times squared. All right, which is just what, r is equal to what, final velocity cos what, theta 30, all right, times the t2 now that we are from finding this one, the total time of flight, so you put 1.53 like that. Okay, so the range now will be what, the final velocity, sorry, so the initial velocity, let me just punch it at once, so I'll have now 15, all right, cos what, 30, okay, then open bracket, then you punch now. All right, so if I punch on my calculator, all right, so that is 15 cos 30 times, all right, 30 times 1.53. Okay, that is giving me what, that is giving me what, when you multiply that, it is giving me what, so my range is now what, my range is now what, we are looking at the total time now, I mean the range, so we are putting that 1.5. all right, so this is giving me what, 25 8.3 meters. You know, this is just the range, so it will always be measured in meters. All right, so this is how you can calculate. Though my calculator, I'm doubting my calculator, but this is the way you can achieve these things. All right, so this is the case 1 of a projectile motion. Let me give you case 2, of which they have been bringing questions and you saw it on the screen there. All right, so let me give you that. Okay, so that's how you can work out this. So make sure that you at least what, okay, I'll leave the, so let's go to the next question, or just next scenario. So we need to see different scenarios. All right, so suppose you are given a projectile, just a bit, suppose you are given a projectile to say let's say you are given a projectile to say it was what, so to them, to a certain height, let's say to what, 200 meters. All right, so let me say 200 what, 200 meters. Okay, so this 200 meters, then a projectile now was what, thrown as what, then it drops like that. All right, so for this one is the situation whereby, let me just go back, let me just take you back there. All right, so this is the one we want now. All right, it was what, projected at a what, at an angle. All right, so now this, it has some certain height, it has also some certain height, so this is the one we are dealing with. All right, so now what we do is, no, we are dealing with this one. So what we do is, they have been bringing this question, so let's see now. But before that, you need to know, sometimes you can be asked to calculate the what, to calculate the the displacement, or just the shortest distance. So the displacement will be what, will be to reach there. So you can just use the value that you have here in the x, and also in this one, use Pythagoras to find this r. All right, so that's how you can calculate what, the displacement or shortest distance. You can be asked like that, so expect all those things. Suppose now, so it was now trajectory, let's say trajected at a what, 20 meters per second. Then at this peak, we know it what, the final velocity is what, is 0. That data should always be in your mind. All right, so there's also time from here, all right, to reach that point. Okay, so sometimes we can analyze from that angle, then you'll be able to add this value. But for me, I'll just get it from here to say this is my range. Coming. All right, so that's my range. So this trajectory was what, trajected at what, at 25 degrees Celsius. All right, so now let's see. So the questions that I'll give you is, one, calculate what, calculate, you're going to calculate what time to reach what, the maximum what, height. All right, or just calculate the what, time to reach the maximum height. All right, okay, so one, I'll say calculate, let me say calculate the height. All right, then 2, calculate the height. 2, time of flight. All right, then 3, that's now B. Now C, I'll say calculate the what, the range. So the other thing is, the other one, I'll say calculate the what, calculate the displacement now, of which I've been wanting you to what, to see. All right, so this is the one. So what we are going to do is, we'll say we'll say now, just collect the data. There's nothing difficult here. All right, collect the data. You collect the data and everything will be okay with you. All right, so what we do is, now you say, okay, you say now, since I want the height, so the height now is what, let me say this is the height now. All right, so for me to calculate the height, well, I have the data such as what, initial velocity. All right, I have the data also such as what, final velocity. All right, of which it is 0. This one initial, it is now, we are going up. All right, we want to calculate that height at the peak there. All right, so we have what, v0 sine what, theta. All right, so that's the height that we have, I mean the velocity that we have. The other thing, I have g, which is now negative what, 9.8. okay, what else do I have? I'm sure these are enough. Okay, so I'll go to a question whereby it doesn't involve what, time. So the only way I can find height or just the distance in those 3 equations that we have, I'll use this one to say final velocity is equals to u squared plus what, 2gh h, or just the height, like that. Okay, so what I'll do is just to replace now the values. All right, so once I replace the values, final velocity is 0, then is equals to initial velocity is what is now in the y, so I'll say v sine what theta, like that, then plus this is 2, now negative 9.8, all right, h, like that. So I'll take this one to the other side, so to have a positive, so I'll have 2, when I multiply, in fact, that will give me 19.6, right? So that will give me 19 point what 19.6. so I'll say this is 19, here is 19.6 the value, so I'll say 19.6, all right, h is equal to what, final initial velocity was what, 20 sine what 25, all right. So when you punch that on your calculator, that will give you what, by the way, it was squared here, remember it was squared, as you can see, even 0 was squared, but it still gave us what, 0, so this will be squared like that. Okay, hope that is clear. Then you divide throughout by 19.6, you divide even the 19.6, all right. So then we have our h is equal to what, once you do that, then you're going to have what, you're going to have what, punch that on your calculator. Then for me it is giving me what, height as 0.18, all right, so meters. All right, you can put 2, but I've left the other 2, so this is the what it is giving me. All right, so that's about to height at this point. So we have calculated this height. All right, so we have calculated this height is equals to what, that. Okay, so that's it, that is it. So let's go to another question. So our height now is what, 0.18, so that's the maximum height, so should be in meters, by the way. Okay, so now to calculate b, just gather the data and you know what to use. Don't even master it. For me, I don't like mastering for me, because some people, they actually you know, it's not easy to master these 3 formulas. So what you do is, now you say, let's go. So what we do is, now you say, we want to now to calculate the time of flight. First to calculate the time to reach here, then again another time to reach here. So we'll see what we'll do. All right, and if for us to calculate what the total time, we'll see what we can do. Okay, so now looking at the data that we have, the only data to reach this point. All right, so we are calculating now what, time of flight, so we call it what, time of flight. All right, so time of flight is the time to reach here, so we'll calculate time to reach at this point. So I'll calculate only to time to reach at this point first. So I'll say the data that I have from here to there is what, from here to there is only what, v initial, all right, which is now in the y-axis, which is v0 sine what, theta. Then I have also final velocity as 0, then I have gravity, which is now negative 9.8. all right, I'm looking for what, time. So the only equation that I can see is what, this one, which is say final velocity is equals to what, initial plus, all right, so initial plus what, a t or ag, all right, I mean not ag, gt. all right, so from here, then what I can do now, I know this is 0, so 0 initial velocity now is what, v0 sine what, theta, then plus what, negative what, 9.8 t. all right, so I'll take this t to the other side, those it will be t is equals to this v sine theta, all right, divide by this 9.8. when it comes, you know what I'm doing, so you say this is 9.8 now. Okay, so now my time will be what, final velocity, the velocity that we had is what, 20 sine what, 25, all right, over what, 9.8. then our time will be now what, when you punch that on your calculator, that will give you, for me it is giving me 0.8 what, 62 seconds. all right, so that's the time that it took to reach that maximum. all right, so this was just time of time taken to reach at this maximum point. all right, you can also gather some data again to reach what, to reach at this point. Okay, So that's what you can do. So you can calculate that time again to reach at this point. Okay, but as for now, let's just pause it like that. So I've calculated the time to reach this peak. All right, so now you can also calculate that time again to reach at this point. All right, okay, depends with the data that you have now. Okay, so that is it for this one. They will ask you questions like that. Then let's go and calculate. So for this one, the value for time of flight is maximum time to reach this point, not really time of flight. Time of flight, again, I'll come to that. Now we'll need to do what? To add times 2 to reach at this point. All right, and also this point. We'll get to know that. So for now is what? T1 is equals to what? 0.862 like that seconds. All right, then what about the range? How do we calculate the range? So even the range, you just gather the data. You know what? There are only 3 questions involved under trajectory. So I mean projectile motion. So you just have to know those 3 equations, of which we studied in secondary level. Okay, so now how do we calculate the range? All right, how do you calculate the range? How do you calculate the range? So before I even do that, see, I've calculated this time. Let me show you how I can also calculate this time to reach what? To reach this point. All right, to reach this point. Okay, so that we calculate the fully total time of what? Total time of flight. So what I'm going to do is I'll bring this equation to say, because the data that I have the data that I have is I have now the height, because I calculated the height, right, which is 0. What? So I've calculated that height. All right, let me just calculate that one so that we forget before I even calculate the range. So the height that we got was what? 0.118. So from there to there we can add just to have the height. All right, so now we are at this point. By the way, I'm just I don't know why I've done this. All right, so this will be now our total what? Our total height. All right, then this is the height that we have. Then here we have what? 200. Okay, so what we are going to do is we'll say we are going to say we want to calculate the total what? The total height. We know now we have the total what? The total what? We have now the total height. All right, we have the total height. So the equation that I can use, which involve some time, because I mean which involve final velocity, everything like that, and also okay, let's see, we are now going down, right? We want to see the total time of flight. So we have that distance, and also that for that 0.18 we just reached at this peak. What about just reaching this point? All right, so what you are going to do is we'll say I'll bring this equation which involve what? Height, and also it has the data of what? Of initial velocity, and also the time, because I'm interested in the time. Then I have what? 1 over what? G t squared, like that. So what I'm going to do, the data that I have this height, I have also initial, I have also time I don't have, and also I don't have time. It can be some kind of quadratic. Let's see. So what I'll do, I'll add this to find it. I add this one on top, and also the 200 that we have. So I'll say 0.18, all right, plus 200, all right, is equal to the initial velocity. Now the initial velocity is now what? 0 at this point, because we want to start falling. We are at this peak, by the way, with that height that we added. That's the height at that peak. All right, so that's the maximum height from the bottom there. So then what we do is we write that's now 0, all right, times t, all right, then plus half, because it's 0 velocity at the peak there. That's why I've written this 0. All right, then I'll say my now g is what? Positive, because I'm now falling. So this is 9.8. all right, then squared, like that. So we add this, you give you what? It will give you what? 200.18, like that, is equal to what? That is 0, right? So we forget. So that will be now you divide that 9.8 times 9.8 times what? Divide by 2. You can say 9.8 divided by these 2. So that will give us what? 4 point what 4.9. all right, 4.9, then t squared. You can see that we can divide throughout by 4.9. all right, divide by 4.9, then that will be now t squared is equal to, we divide that, so 200.18 divided by what 4.9, so 200. all right, so that's 200. all right, so that's 200.18 divided by what 4.9. okay, so that will give me what that will give me, okay, so let me do this. Let me say this will be now under the root, so I'll say 200, because these have cancelled, 200.18 over divided by 9 point what, I mean 4.9. okay, so now you square root, I mean you remove that root, so that will be now t is equals to what, the root of everything here is what, it is giving me, let me see, okay, it is giving me 6.39 there. okay, I can put also 5 blah blah blah. okay, let me just put seconds there. all right, so that is it. okay, so that is it about time. Now this is because we started at this peak, now falling down, this is the time that we gathered. all right, so now to fully calculate the time now which is needed, because we have calculated the time from here to there. all right, and also we are from calculating the time from here to there. all right, so the total time of right now will be the addition, so total now, all right, total will be now so I'll name this one as t2. so the total time now, this was our t1 by the way, so the total now is t1 plus what t2, which is t1 we had what 0.8 seconds, so 0.862 seconds plus 6.395 seconds. so when you add that, that will give you what 7.25 seconds, like that. so this is the time that was supposed to be here. all right, so this is the time, which is 7.25 seconds. all right, so now we calculate the range now. all right, so how do we calculate the range now? This is the very simple thing. You look at that equation which involve what time and what height, so we'll be able to calculate the range. so that is now d, no c. okay, so now what we are going to do is we calculate the range by saying, sometimes we can master the formula to say this is what final velocity, then t, like that. okay, so in the x now, that will be what v0 cos what theta, then time. so it came from these guys, so don't be confused. We brought this from where? From this equation, to say we want the height or just the range. all right, so which will be given with the ut plus what half what at squared. oh, this can be g sometimes. so what we do is we said there is no gravity or no acceleration in the what, in the x, so just say r is equal to what, this initial velocity is given by what v0 cos what theta, then there's time there, then plus this g is 0, so we'll definitely get 0 there. so that's why this one is just the same that we have here. so I'll continue. Range is equals to what, v0 is now 20, we are 20. all right, cos what 25. all right, then time, now the time taken, the total time that we had. all right, this is the one we are from calculating. The total time is now what, because we want to really see the range from here to there. This one depends on the time that has been elapsed or just taken up there on each motion or each step the ball or just the trajectory was taking. so we calculate all that time, so we bring that total time, which was what 7.25. all right, then we say now the range is equal to what, the range is equal to what 20. once you punch that on your calculator, that will give you, let me punch. all right, okay, so if I punch on in my calculator, that is giving me what 131.41. all right, meters. By the way, it's meters. Okay, you can put 4 there. There's 4, by the way. So 131.414 meters. So that is it. Okay. So the other thing that I said, they can ask you, get the displacement or just the what, the maximum height or the shortest distance. So the shortest distance will be gotten by this. All right, so that's the what, shortest. All right, so this is the displacement. Displacement, we're talking about just straight to the what, to the final destination from the initial what, starting point. So now we can see we have this value here, which is now 131.414. okay, so we can use Pythagoras. So we can say now the displacement squared is equal to root of these 200. All right, 200 squared plus what, 130 what, 1.414 squared, like that. So that will give you what, you can punch on your calculator. Then you say 200 squared, all right, plus 131.414 squared. Okay, then root. So that will give us what, the shortest distance. That will give us what, that will give us 239.3, like that, then 1. So you put meters. All right, so you can see this is 200. So this is the shortest distance, all right, that we can have. Okay, so that is it about directional motion, guys. So solve more questions, and also other questions, send more questions, guys. We'll meet in class. We'll talk about them. So that's how you can just master the way we have been gathering the data, and everything will be very easy for you. Thank you very much for watching the video, and don't forget to subscribe. Just subscribe. The offer is free. Okay, the lesson is free, but you are failing to subscribe. Someone has given the effort, they have committed themselves to help you, then you don't want to subscribe. Subscribe, guys. All right, it doesn't kill.